Hi, welcome back to another session in our series called Game Services. It's still me, Olivia Klose, software development engineer at Microsoft. With me is my teammate called Christopher.
Christopher, also software development engineer in the same team as you, Olivia.
Really?
Yeah.
Okay, and the second session is about Azure Compute. In the first session we've done an overview of game services, why a game developer should bother about Azure in general. Now we want to go more in depth in some of the building blocks pretty much that a game developer would encounter when developing a game and leveraging Azure. The first one here being Azure Compute, and I'll hand over to you.
Thank you. Yeah, so first let's define what is a compute scenario for a game. So I kind of define it as this. So if you find yourself in a position where you need some kind of code to be evaluated and run on the server side. So you have a game and a game client. That could be a web client, it could be a mobile device, it could be an Xbox or a PlayStation. But if you ever find yourself in a position where you want some of that logic to run on the server side, that's what we're going to talk about right now.
Sounds good.
So let's talk through some of the scenarios that could be valid, so why you would consider using this kind of compute resources in Azure. And one of them would be multiplayer games. So if you have a multiplayer game, a game that you play against someone else, could be against one other person as a turn-based game, like chess or a card game or something like that. Could be a multiplayer, like a synchronous multiplayer game, like we used the reference to Halo before. Okay. So those kind of first-person shooter game or any kind of MMO, like massively multiplayer online game or something like that.
Okay, so that's the first scenario, multiplayer
That would be the multiplayer scenarios. But then you have the rest of the games that also could benefit from some kind of server-side logic. We call them service games. So games that benefit from having a backend that in some way helps the game become better.
Okay. I see some word here, authoritative logic. What exactly does it mean?
So it means if you have some kind of logic that runs on the server side that is more important or that decides what is the truth. So quite often in a game scenario, in games, you have logic running on the game clients because you want it to be fast and responsive. So you cannot just offload everything to the server. You need to run some things on the client side anyway. And quite often you run the same kind of code on the client side and on the server side. And if the server side is the one that decides whether if something happened or not, then that's what I mean by that.
Can you give a concrete example?
So for example, a game where you first-person shooter game. So you run around and you shoot someone. You think you hit someone.
Yeah.
That might be true, but quite often you let the server run the physics simulation, so the server runs the game simulation and decides whether you actually did hit or not. The client will only evaluate if it thinks you hit or not. And that's why you sometimes experience what my kids often refer to as lag. The game is lagging again. So you can see someone jumping, or you can see you thought you hit someone, but then you didn't. Because the server decided it wasn't the truth.
Okay, that makes sense.
So that would be so many games could benefit from being serviced by a server side. It could be the multiplayer game, but it could also be other ones. So for example, achievements. So if you have a game where you can achieve some kind of rewards, you could implement that on the client side and say, hey, congratulations, you've just played the game for 5 days in a row, you win this kind of award, this achievement. But you can also implement that on the server side and then no one could cheat.
Okay, and some examples of a service game could be The Walking Dead, for instance, because I see a service game could be something that has updates coming up on a regular basis.
Absolutely, so Walking Dead,
Hitman,
the Walking Dead No Man's Land, or it could be Hitman, or it could be any kind of game that connects to the backend.
Okay.
And the backend makes the game better in some way. There's another type of scenario as well where you offload game logic. So if you're running a game on some kind of device where resources are hard, there's only a limit of a fixed amount of resources that you can utilize on that device, then you would like to offload as much as possible to somewhere else, and presumably the cloud then, to do that kind of logic instead. So it could be rendering stuff, it could be running server-side logic like the physics game engine, it could be running AI in the cloud, etc.
Yeah, okay. So can you mention any examples, like in how have some game studios have made use of an offloading game logic?
So one very typical scenario would be the driving game Forza, that uses that has what they call the drivatars. So that is the AI that you drive against, and it's actually bots running in Azure that plays the game with you.
Okay.
So instead of having that logic run on the client, you can stream down the logic from the server. It would also be, there's another game coming out called Crackdown. It's already been showcased on build conferences and stuff, where they run physics simulation on the cloud to help figure out how buildings are falling down, etc. So your game can instead focus on rendering very nice experience for you as a gamer.
Okay, nice. So this is just an overview of some scenarios, and we are now going into each scenario in more depth.
So these are some scenarios, and what services would you consider if you run into any of these scenarios? And we spoke about some of these during the first session, like virtual machines. You set up virtual machines yourself. Any operating system would fit. If you want more than one, you can use the virtual machine scale sets. It will help you scale out to more than one. The container services would be a good option if you want to run your services inside containers and you are used to doing that already. Service Fabric could be good as well if you want to host both stateless services, but if you want to build on top of the actor-based framework in Service Fabric. Quite often you would need to have some kind of API to connect to as well that doesn't really provide the multiplayer experience, but something that does something else. And the web apps and the app services in Azure would be an awesome place.
I see.
If you want to do a lot of things in a short amount of time, then Azure Batch might be one of those things, like compute a lot of things in a very short amount of time and have some kind of thing spin up. It's almost like HD Insight and Hadoop, but you can run any kind of custom job, really.
In Azure
really
Batch,
yeah.
I see.
So let's go through some of these sample scenarios, and then we figure out how I would think what kind of services I would use to solve these scenarios.
Okay.
So what if we have a session-based multiplayer game with these requirements? So it would be a game built using, for example, in this scenario, Unreal. So Unreal is a very popular game engine. You want to host the game services part of that in Azure. You have a requirement that says it should scale on demand, and you would have approximately 64 players per session playing on those. So what considerations should you have then? So I think it's important to know then that you have chosen to build a game using Unreal. So the server component would be an executable that would be the output of you compiling the game.
Yeah.
So you will get an executable that you will need to run somewhere. Latency is going to be important because running any kind of game like this,
especially since it's a multiplayer game.
Yeah, so it's going to be, it's important that we put it somewhere close to the game, to the end user. And the servers, the game servers, so it's not the VMs per se, but the game processes running need to be reachable as fast as possible. So I've written here, has to be reachable directly.
So why in quotation marks?
Yeah, it's more, it doesn't really has to, but it's more, if it could be reachable directly without passing through any load balancer or any kind of router or whatever, it would be a good option because it would be faster.
Okay, so ideally should be reachable.
Ideally, yeah.
I see.
And many of the game engines out there, not all of them, but many of them run and are optimized to run on one core, on one thread. So using really big machines with many cores would then imply that we need to host more than one game server process per each VM in order to utilize the full virtual machine.
Okay.
So things or services to consider for this scenario would be virtual machines again, scale sets if we need more than one, if we can. The container services if we like that approach to deploying and running our services. Service Fabric could be one, and Azure App Service would be one as well. So let's see how it could look like in architecture if we were to put it into a diagram like this. So G stands for games here, so that's the game client.
Yeah.
And would probably need to connect to some kind of API to ask, where should I connect to?
Okay. So
this is a session-based game. So think of it like Halo, or one of the more famous one would be Counter-Strike or a similar game. Or it could even be Minecraft or a game like that. But the game would then reach out to some kind of API and ask, where is my server? Where's my session where I'm going to play?
Yeah.
The API would then respond back with an IP address or some kind of address, perhaps a port number as well, and say, here's your session, here's your server, connect to it on this port. So we would host the GS, stands for game servers. So the game server processes would be hosted on top of them. And we would have a web job or something in behind that would act as a spider in this, or a spider, more like the brain in this one.
The controller?
The controller, yes.
Okay.
That would act like figuring out, do we have enough game servers running or not? Do we need another one? How many servers are coming up right now? Do we have enough?
And here it is like one game server per VM. Obviously.
So it could be, so if we can optimize this one to have small VMs, that would be good in that way because we don't have to solve the problem of having more than one process running per VM. But quite often we want to have bigger machines and we might consider using more than one game process per core. So it's something we need to figure out ourselves and implement in code. Probably going to use an ARM template to deploy all of this at once.
Because you love ARM templates.
I love ARM templates. But we might also use ARM template to deploy each and every game server. So the game servers themselves could be deployed using ARM templates. So the ARM template would contain information about the VM, but also about what's going to be on them.
Okay. So something like nested templates?
Yeah. So you can have nested templates. You can have an ARM template that has a dependency on other templates. So we could use that. But probably this web job, the brain behind this here, would be something that would call into the Azure API and say, hey, I need another VM to spin up now because I'm predicting someone will need that one in the next few minutes.
Okay, so the web job here is something like the orchestration here.
Yes.
And then the game itself would call into the web app to know where to actually dial in or where to reach out to.
Yeah.
And therefore connect to a game server.
Yeah. And you can see the similarities here in this scenario and this architecture. It's very much similar to what you would get from some of the container-based solutions, the open source solutions that are already doing this for you. And sometimes those would be a better option, but sometimes you need something more customized like this. So let's continue with another scenario. So we have this other scenario instead where we have a game written in C#. It's a mobile game. It runs on most devices out there. It's written in C# and Unity. Okay. So Unity is another game engine, very popular for these kind of games. There should be a possibility to push out new levels and things inside your game from the server side.
So pushing out updates.
So updates like that. And there should be a leaderboard attached to this game. Things to think about when you're in this kind of scenario would be that many Unity developers are using C#. So C# is one of the script options that you have inside Unity. So it could feel very convenient to continue to use C# on the server side because it's the tools they're already using. Platform as a service would make a lot of sense because they don't need to handle the servers themselves.
Okay.
They would only have to write the code, perhaps C#, Python, or whatever. But
just focus on the stuff that you actually love doing.
Yeah. Focus
Coding.
on making a great game that people love to play. And some of the services to be considered in this kind of scenario would be similar to the ones
Pretty
before.
much the same as before.
It's very much the same, but the virtual machines is always there. It's like the base option. You can always use them to, And the scale sets we already spoke about. The container services, of course, Service Fabric, and the app services that are available. So a little bit depending on what you intend to do. So for example, the Service Fabric, if you're writing this backend and you have the ability to model the problem you're trying to solve with actors, we spoke about it in the previous session somewhat. Mm-hmm. It could be a good idea to figure out and at least evaluate if building an actor-based architecture would make sense for you. But it doesn't always do, but it could. One solution to this could be something like this. So you have G, the game again. Yep. It connects to a web app. Could be running in Azure Web Apps. That would be the API. Like, this is my score, this is my high score, please save it somewhere. It would be saved in a database. Perhaps you're going to use a cache behind there in order to speed up the process. It's very much like a traditional 3-tier architecture that we see in many business solutions today.
So when you say using a cache to speed up the process, what process exactly?
So that would be speed up the process of reading the data, perhaps. So returning, instead of hitting the database all the time. So if many people are hitting your leaderboard, you could just have a cached version because it's probably going to be good enough.
Updated really quickly as well.
Yeah, and probably good enough for a leaderboard. So very similar to 3-tier architecture. You can have your game download things directly from blob storage. So blob storage is one of those services in Azure that's very well suited to be exposed directly to the game client. So you can give out temporary access to blob storage. So without just opening it free for everyone, you would give out a temporary access. We call it a SaaS token.
Yeah.
And you give it out to the game client, and the game client could then download some new content. It could be a new skin for your avatar or whatever in your game.
Okay.
And if we then had the option to design it from the beginning, thinking about Service Fabric and then combining the database layer, the cache layer, and the logic into one could make sense if you could use this actor-based framework.
As we've already discussed in the first session.
Yes. And this is an actual, like, I'm showing you this one because it was already disclosed by IO Interactive at a conference in the game conference in Sweden called Nordic Games.
Okay, so and IO Interactive meaning the game Hitman?
So IO Interactive is the game studio behind the game Hitman. And this is one part of their architecture and how it looks like, where you can see the game client is actually connected to our previous version of web apps. It's called the web roles that we used to have there.
Yeah.
And we can see they're using Orleans instead of Service Fabric. But it was due to some reasons that a decision had to be made at the time when Service Fabric wasn't really available.
I see.
But you can also see that the Hitman client would then download resources from blob storage after having that SaaS token, etc., etc.
Okay.
So it's very much like it could look like. I just want to tell you that this is not the full picture how that architecture looked like, but it's
part of it.
Part of it.
Okay, and resembles really much to the architecture that we've seen beforehand.
Yeah. So what if you don't want to start from the beginning? So if you want to have some help. So we have started this initiative. So we call it Nether right now.
Why Nether?
So you could argue that it's from our manager that comes from Netherlands, but it's actually from the underground, the underground world inside Minecraft. So if you build a portal in Minecraft, you can transfer yourself to Nether. So it's going to be full of lava streams and dragons and stuff. So we needed a name, so Nether was a good one.
Doesn't mean that this initiative contains a lot of dragons and lava.
Not yet. So Nether is available on GitHub as an open source project. So you can go there and it has some code for you to start with.
So can you tell us again what the purpose of Nether is?
So the purpose of Nether is to give you a starting point, like a building blocks. You could see it as an already built solution for your game, but it's probably more it's probably better to be seen as something you can build on top of. So it has some building blocks for building leaderboards. So if you want to have a leaderboard, we have an implementation of leaderboard in Nether. So you can just connect your game client to the Nether solution, and you would be able to send scores to it and retrieve high score lists. It also has player management, and it has analytics capabilities. And there's more coming. This is open source. We like your help. So if there's anyone out there that want to help us, please create a pull request, clone, fork, create pull request, and help us develop this one.
Cool. Thanks, Christopher.
Thank you.
So wrapping up the session, we talked about Azure Compute in much more detail, looked at, mentioned 3 typical scenarios, first one being multiplayer, the second one service games, and then the last one, the offload logic, pretty much?
Yeah.
Went into more detail in the first 2 scenarios, looking at architecture patterns, service fabric versus like web apps, and then also had a look at the Hitman architecture as well. So it's not just very theoretical, it is actually being used and implemented in production as well. And if you have any more interest in Nether, for instance, feel free to reach out to us or contribute. We would love to have your feedback, and with that, see you in the next session.
Thank you.